Hi, my name is Stuart Lynch. I've created a number of videos going over the various applications of enums in Swift. In this video, I'd like to focus on associated values. As well as storing a simple value, enums can store associated values attached to each case. This lets you attach additional information to your enums so that they can represent more specific information. In this video, we'll see how we can work with associated values, and as a bonus, I investigate a very special one, the Swift result type, and show how it all ties in with throwing functions and completion handlers. Before I get started, I just want to ask that if you like what I'm doing, and this video in particular, please leave a comment and give the video a thumbs up. You can also subscribe to the channel to get notifications of new releases, and it really encourages me and helps me to grow the channel. So let's go. To keep me focused, I've created a simple playground, and you can download it from the link in the description below. There are 2 pages, and neither of them have much in them, but I have sectioned off my examples using a code closure function. What this function allows me to do is to keep all of my code separated and allows me to, because of the code in a closure, use the same enum or variables over again without having to worry about name conflicts. And it keeps my printouts to the console nice and organized. This public function is found in the sources folder, and if you've watched some of my other videos that use playgrounds, you may have seen this before. It's a technique that I borrowed from the Ray Wenderlich videos. So let's get started. In our first example, I've already created a car enum for you. So let's create an instance of this using the case SUV. Now, if I print car, I see that SUV prints out on the console, but it isn't really a string. So if I wanted to print out this all uppercased, I would get this error telling me that the car has no member uppercased. Well, we can fix this by specifying that the enum car is of type string. And this is an associated type, not an associated value, but an associated type. And then we can use the raw value of the enum, which will convert the case to a string. And then because it is a string, strings have an uppercase function. Now I've covered enums in a previous video, and I'll leave a link in the notes below. I even introduced associated values in that video, but I want to try and show the difference between raw values and associated types in this video more clearly and dig a little deeper. First though, if you don't want to use the automatic conversion of the case to a string, you can override this by assigning a specific string to one or more of the cases, like this. I can create a new instance, and I'll call it car2, and it will be the case convertible. Let me print car2 and car2.rawValue respectively. We see that car2 prints out convertible, but the car2 raw value prints out car with no top. So as long as we assign a string to each of the cases, we can override the default raw value representation. Now I'm going to copy that enum from example 1 into example 2, but I'll remove the string associated type. And notice I said type again, not value. And I'm going to change it to a double. And of course, this gives me an error because car with no top isn't a double. So I'll remove that. And the error goes away. Now we already have an instance of car created, so we can print car, but let's also print out its raw value. This time we still get SUV for the first print, but 1.0 for the second one, because if no override value is provided, the cases start at 0 and increment by 1. So the SUV's raw value is 1.0 because it's a double. So let's assume that we want to use overrides to represent the corresponding price. So let me add some. These are the average prices for these type of vehicles. Okay, well this is fine and good, but not every convertible costs $53,900 or each SUV $38,015, etc. Each make and model varies, so the enum is basically useless. And this is where associated values will come in handy. Let's copy that same enum from example 1 into example 3, but this time we're going to be removing the associated type of the enum entirely. And instead we're going to use an associated value for each of the cases. And we can do this by specifying the type for each case like a function parameter in its definition. It just so happens that all of our associated types are doubles here, but as you'll see shortly, that's not necessarily required. Now, when I want to create an instance of car and specify the case, we need to pass in a double value for its argument. So for example, car.convertible at a price of $56,000. Each instance can assign a different price. If we print car, we see that we get convertible with a price of $56,000. We wouldn't, however, be able to use this price in any string interpolation or anything. If I wanted to extract just the price, what would I do? Well, we can do this by creating a computed property for our enum, and I'll call it price, which is a double, and I'm going to switch on all of the cases. What we do is we switch on self, and since we need to cover all of the different cases, I'm going to let Xcode do the code completion for us. And we see we get the syntax required. It uses the argument name and then creates a constant that we can use in our switch. In our case, all we want to do is return that price for each case. Now I can use print car.price. Now what if I actually wanted to get the car type of our enum as well? Well, we could do this again by creating another computed property, and I'm going to call it description, which will be a string. I'm going to start exactly the same way as we did in the price example, and I'm going to switch on self and let Xcode generate the cases. But I don't need to use price at all, and there is no requirement in our switch statement to include the argument, so we can simply remove them. And I'll just return a text representation of our vehicle type. And now we can print out our instance's description. So as you can see, an enum with an associated value with a computed property can be very powerful. Let's take a look at another example where the associated values for each case are different types. Within example 4's block, let's first create an enum called size. And it has no associated type or values for any of its cases. The cases are small, medium, and large, and we can write all of these cases on a single line. Next, I'm going to create an enum called menu item that has 3 cases. And Coke has an associated value of size, which is of type size. Burger has an associated value of quantity, which is of type int. And fries has an associated value of size, which is of type size as well. So let's create an order that is an array of menu item for, say, instances of a small Coke, a burger with a quantity of 2, and fries whose size is large, just the way I like them. Well, now I can create a print function that will print out our order. So again, I'm going to let Xcode generate the code for all cases. And for each case, I'm going to print out the menu item using string interpolation. So now if I want to print out our order, I can simply call that function, passing in our order. So that's enums with associated values. You might want to stick around for the next bit though, as you may find that it will clear up some things for you. I'm going to talk about throwing functions, completion handlers, and the switch result type. And hopefully by the end, you'll understand the relationship they all have with an enum and associated values. I'm going to take this slowly and break it up into two parts. I do want to look at the Swift result type, but before I do that, I want to take a look at how we did things before the result type became available to us in Swift 5. Let's take a look at a bit of a fabricated example. I'm going to create a function that may create an error. And it will be a throwing function, and throwing functions are those that will flag up errors if problems happen. And Swift requires you to handle those errors in your code. And to make a throwing function, you just write throws before the function's return value. So the function I'm going to create is one I'm going to call quotient that has two parameters, a dividend and a divisor. Both will be doubles. An error will be thrown if our dividend is divided by a divisor that is 0. You can't divide by 0. So if you're not familiar with throwing functions, you can watch this video that I created, and I'll leave a link in the description below. But before I create this function, then let's create an error enum that I'll call div error that conforms to the error protocol, and it has one case only, div by 0 error. Now with that error created, we can create our function, and as I said, I'm going to call it quotient with dividend and divisor as our parameters, and it will return a double. But because it may create an error, if our divisor is 0, we can designate it as a throwing function here by adding that keyword before our return. It'll throw an error if divisor is equal to 0. And the error that we want to throw is our div error with the case of divide by 0. Otherwise, we can just return dividend divided by divisor. Well, we could use this function now, and it's arguably better because this will catch the deadly division by 0 error. Let's say now that we have some asynchronous task that when we want to call this, it does a bunch of stuff, and then at the end it calls this quotient function. It takes so long to perform that it would freeze up our UI. So we don't want to hold up that UI. We need to create a function that returns our result as part of a completion handler. With a completion handler, my calling function to this fictitious function would look something like this. So if I call the function doLongDivision, we'll pass in our two numbers, and then the completion block is going to provide us with an answer that we'll be able to print out. So that's how we're going to call the function. So let me comment this out now, and we'll come back to it after we've created the function. But I'm going to leave it here for reference. So if quotient was a regular function that didn't throw, we could write our function like this. It has two parameters, both doubles, and another one that's an escaping closure that provides a double as its argument. There's no return value for the closure, so it's just void. And the concept of completion handlers and escaping completions are covered in another video that I'll leave a link to in the notes below. Now, this function will do some other stuff that takes a long time, as I mentioned. But once it has, we can then let our answer be our new quotient, passing on our two numbers. And once that's done, we can call our completion, providing the answer as the function argument. Now, our commented out caller would work fine here, except for one thing. Quotient is a throwing function, and so we need to do a do, try, catch block. We will try to perform the quotient function and assign it to the return answer before passing it on to our completion. If it fails, however, we need to catch the error. So with our function definition as is, we're not specifying what the error type might be, so we'll just print it out. If we recreate this commented out function now, let's pass in two numbers, say 15 and 5, and we'll see that our completion handler is providing us with a double, so we'll just call it answer, and print it out. Great, 3 is the answer. Now if we change num2 to 0, then the catch block will get executed and our error is printed. Well, that's how we used to do things. The problem that I have here is that the catch is happening way back in our do-long division function, and not here where I'd like to respond to any errors and present the user with some kind of notification. Now, I could return a double and an error and deal with it that way, but now there's a better way to do this, and that's using the result type. With Swift 5, we get the result type. And if we look up the definition, we see that it's really an enum with 2 cases, a success and a failure, each with an associated type. And those associated types are generic. In the case of success, they've used success as the generic type. And in the case of a failure, it's also a generic type as long as it conforms to the error protocol. And they've just called that generic type failure. So when I was first introduced to the result type in Swift 5, I was somewhat confused. And I've got an entire video on this. When I realized it was simply an enum with 2 cases that have associated values, it made much more sense. So let me show you. Let's just copy the entire code from example 5, except for the call to do long division, and see if we can use result instead. So in our do long division function, instead of having a double as an argument for our completion, we can use a result type. And it requires us to specify the 2 types that we expect. Well, the success type is our answer, and that's a double. And the failure type is a div error. Now our completion needs to change. It no longer has a double as the argument, but rather a result, which is an enum. And our enum has 2 cases with associated values. So if we're successful, then our result will be the success case using the answer as the associated value. Now if there's an error, we don't have to stop here. We can call our completion handler here using the failure case and the divide by 0 error as the associated value. This means then that we can handle our successes and our failures at the call site. So replicating the call to do long division, we can pass in our 2 numbers, and we'll see that our completions argument is going to be a result, enum, with a double and div error as our associated types. And since result is an enum, we can use a switch statement to cover both cases. Now this time letting Xcode fix the error isn't perfect, as it can't infer the associated types since they're generic. But we know that the case success is our answer, which is a double, and the failure case is an error, and we know that it is of type div error. So we can print out the answer or print out the error just as before. Running this with input values of 15 and 3, we get the result of 5. And this time, if it fails, we can print out the error, and it gets printed out now, but this time it's being called or printed at the call site. So I could present the user with a notification or an alert. Now I can do one last thing to fix this up. I'm going to go back to my enum for div error and create a localized description for our error. And this is a computed property of type string that returns an NS localized string. It has a couple of overloads, but the one we want is the one with a key and a comment. Both are strings. And the key string is what is going to be used as the localized description. So we can type something here that's appropriate. And we can just leave the comment as an empty string. Now the comment string is ignored by the application. If you are going to be localizing your application to multiple languages, the comment string is used for the translator's benefit to add meaning to the contextual usage of the key where it's found in your application. Now, instead of printing out error, we can print out error.localizeDescription. You may have seen that before. And that's it. I hope this gives you a better understanding of associated values and how you might want to use them in your code, and at the same time, cleared up any issues you might have had with the result type. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.